Hi everybody, welcome to another Spectrum Economics video. As you can probably hear, it's a little bit of noise in the background. It's pouring down with rain today, so it's a bit of a wet day out there. But hopefully, if you're watching this on a wet day, it depends on when this video comes through. Hopefully you'll enjoy listening about cost-benefit analysis again, and the topic of today is going to be sensitivity analysis. So this is just breaking down some of the key points that I've talked about in some of the other videos. I think it's the first video we touched on sensitivity analysis. I'm going to focus purely on sensitivity analysis today, and there'll be another video following up in regards to how sensitivity analysis can actually be put in a model and how we can come up with different distributions of benefits costs, benefit cost ratio and net present value. But today I'm just going to cover off on the key points and the key aspects of sensitivity analysis and why it's important. So the first thing we've got to think of is risk. That's right, anything you put into your model, anything you put into your analysis, there's a risk that it may not happen. And that could be it could be bad, you know? Like for example, your benefits could be higher than you anticipated or it could be lower than you anticipated. It could go either way. Risk can be positive or negative. And the same with costs as well. In fact, if there is, might say, insufficient information or incomplete information, there's actually greater risk that your project's results, or what you get anyway in your main case, should we call it, or your central case, won't be particularly accurate. In order to fill in those gaps, we have what we call assumptions. And assumptions are very important, and it's important in the sense that they don't just come out completely out of the air. Assumptions need to be backed by something, and you'd have some supporting evidence, or you have some evidence maybe from some prior analysis supporting these assumptions, or why the assumptions are logical and why they may fill the gap in your cost-benefit analysis. And these assumptions, the important ones anyway, affect your key drivers. And there's a number of key drivers we've got to look out for. Like, things like population growth is obviously a very big one when it comes to benefits, especially talking about future benefits. And if you have a project that's got benefits going over maybe 10, 20, 30 years, the growth rate could be quite critical, and it could be quite a key driver of your benefits and of your demand, of course, which then drives your benefits. So what is most important in the sensitivity analysis is looking at those drivers that cause the greatest change. And sometimes that's a little bit difficult to recognize, but basically you got to know, it goes back to your key drivers. What are those key drivers? And some projects could be very, very sensitive to certain drivers. Some of them may not be. Some may not be sensitive at all. You may actually have to have a very narrow range of results. So in a sense, that is good because you've got more certainty about your results. But generally, in a sensitivity analysis, the most important stuff is that it's going to cause the widest fluctuations. So how do we show those key drivers? How do we bring out those assumptions? Normally, when you do an analysis, you'll have what we call parameters. And there's also another thing known as variables. Variables often depends on your project, on what you're doing with the project, and you actually have some control over what those variables are going to be. Like, for example, how big is your hospital going to be if you're building a hospital? How many doctors are you going to hire? And these sort of things would come in as your variables, whereas parameters will be looking at certain things like a deterioration rate, for example, wear and tear on buildings and things like that. That would be a parameter. And our assumptions around that would affect, like, for example, deterioration of a building. It could be linked to weather and stuff like that. And again, if you were talking about very serious weather, it causes a lot of damage, then your building would deteriorate a lot faster. And all of that would then feed into your parameters. And this is where we apply our sensitivities, is often around the parameters. For example, I mentioned earlier growth rate. So growth rate would be a parameter. We don't have control over it, but it's a parameter in the model. So it could be higher or it could be lower than what we've entered, and that's going to have an impact on our results. So when we talk about sensitivities, what do they generally affect? Well, in a cost-benefit analysis, you have two things. You have costs and you have benefits, of course. And they affect them in different ways. Like, a lot of emphasis is typically put on the cost side of things, simply because costs, or capital costs, shall I say in particular, being the largest portion of your cost normally, and that normally occurs very early on. So you have quite a bit of confidence normally about what those costs are going to be. And it's also easier to put sensitivities around certain things. Like, there could be fluctuation in, for example, the exchange rate may affect your costs. There could be fluctuation around wages and things like that. There could be fluctuation about how you obtain your resources and things. And And it's a little bit easier to apply sensitivities to these because it's not over a broad area. In fact, there's quite a bit of information and manuals and all that. There's estimating manuals. How about you go applying risk and how you can go about doing your sensitivity analysis that way. And for, like in the transport sector, a lot of this stuff is actually done by the estimators. And there's not an awful lot of work there for the economists. And normally what they would do is they'd produce a distribution, whether it be a normal distribution, or it could be a triangle, or it could be a PERT distribution. And from there, they obtain what we call P50, P90, and P10 values. So for example, a P90 value, that means 90%, or approximately 90% of the time your costs are going to be below that value. Like for example, P10, that'd be 90% of the time your costs are going to be above that value. And then you have the P50, which is smack in the middle. So there's a 50-50 chance your costs are going to be above, and 50% chance it's going to be below, more or less on that, if it's done accurately. And there's a tendency for these to be out, and I think it's got quite a bit of research actually in terms of what we call optimism bias, in the sense that a lot of contingencies aren't included. And to compensate that, I think it's kind of gone the other way, in the sense that a lot of extra contingencies are being thrown in there with very little basis, that's actually jacking up the costs in an attempt to erase that optimism bias, in the sense that a P50 may be more like a P70, and a P90 is almost getting up to a P95, a P99 or something along those lines. It is to avoid the embarrassment of asking for more money based on a P90. But ideally, you know, we don't want the two extremes. We don't want these values to be low, we don't want to be high, we want to be as accurate as possible. And it is difficult because there's a lot of unknowns, even with your cost side of things. The benefits side is actually even more difficult, because your benefits, you're going out 10, 20, 30 years. Like in a transport project, you could be going like 30 years out. IT projects, probably less, maybe 5 to 10 years. Other hard, solid infrastructures, 20, 30 years. Your non-infrastructure stuff tends to be shorter periods of time, so you may have a little bit more accuracy in that. That's the thing, it may be very difficult to understand what your risks are, but it makes sensitivity analysis, in my opinion, actually more important. And unfortunately, sensitivity analysis, it's not conducted to any level of detail. Like we mentioned with the costs, we've got distribution of costs between your P10s and your P90s and all of that. That's typically not done with benefits. And what is done with benefits instead, typically in your cost-benefit analysis, is sometimes just very raw. You'll look at one benefit, for example, and say, what happens if it's up by 20%? What happens if it's down by 20%? That doesn't really tell you that much, because it's very basic mathematics, and that would apply across all projects. Benefits up 20, benefits down 20. You don't understand those sensitivity. So if you go to parameters, for example, this is probably a better way of going about it, is you look at your parameters, for example, like I said about growth. So growth could be 5%. What if it's 7%? What if it's 3%? You'll see greater variance between your projects. Like a project that doesn't depend highly on growth, for example, their benefit cost ratio, net present value, may not fluctuate much. So your benefit cost ratio could be, for example, let's say it's 1.5. So with the high growth rate, maybe it only goes up to 1.8. The low growth rate maybe only goes down to 1.3. Whereas you have another project that's far more sensitive to growth rate, and these projects are probably typically going to have most of their benefits in the later years. So again, let's say we've got a benefit cost ratio of 1.5, and if the growth rate's high, maybe it go up to 3 or 4. But if it's low, maybe it goes down to about 0.3 or 0.4. So there's a much higher risk. And that gives you an indication maybe where you want to put the money in order to reduce risk. Similar thing can be mentioned about your assumptions as well, and that's going back a step even further in terms of what you're assuming. So we talked about growth. So what goes into growth? So that could be your population growth. That could be your growth of your gross domestic product. That could be your growth in wages, and you make assumptions around that. It gets a little bit more difficult, but again, you can see those sensitivities and how they affect your analysis a little bit more clearly. So what I'm going to show you now is the results of a cost-benefit analysis I conducted several years back now. I'm not going to reveal the name of this cost-benefit analysis, but you can see here by the results that we have a massive range of results coming out here. So we had a best estimate, I think, of BCR of 98.26, which is exceedingly high. The reason being that this benefit cost ratio was so high was the cost was very, very low, and the benefits by comparison were very high. So I think we're talking about a couple of million in terms of cost, and almost like 100 million in terms of benefits. So when you get those low cost, capital costs, you tend to get benefit cost ratios that fluctuate a little bit more. But there were certain key sensitivities around another project, whether that went ahead and when it went ahead. So if this other project didn't go ahead at all, you're going to get benefit cost ratios exceedingly high. As you can see here, it goes up to about 160, 170. Whereas if this project goes ahead about the same time as this project has almost no value. And you've got your benefit cost ratio going down to what? 0.75. So it all comes into timing, and this is quite interesting when you've got relationships between projects. And a good way of going about this is actually putting them in a program and actually arranging the timings of these projects to actually get the maximum results. I'm not going to talk about programs today. I've got another video on that you can go and have a look at. I've got a conference paper that will talk about program evaluation and program analysis. So again, these results present a wide range, but how do we know whether we're going to get your benefit cost ratio? It's going to be high or is it going to be low out of all of that? It's like, okay, in some ways it's almost useless in a sense. So I think there's a better way of doing that, and that's actually going back to what we do with costs, but extending that to costs and benefits together. So you may do initially your typical cost, and you have your contingencies and your risk relating to those costs. You can do that. And then you look at what affects both costs and benefits. Probably the larger focus on your benefits and not just your costs, and how that affects your net present value and also potentially your benefit cost ratio as well. So here we are. This is what I pulled out of my model, and I've got another video that will explain how this model calculates distributions. But you can see here with your net present value, you got this distribution. It is a little bit like a normal distribution. I think it's slightly skewed, as you can see, skewed to the right. So you've got these higher net present values because I think potentially net present value, if the right combination of things come together, could be very high in terms of your benefit side. You can get the same with your costs as well, where your costs can potentially be very high as well. And looking over a 30-year period. But there's not too many scenarios, that's why you've got that long tail, that result in those very high costs. And there's more scenarios that land you in the middle where you get that central tendency. And that's where you get a distribution. And this distribution is good in a sense that it gives you your upper and your lower bound. So as we mentioned before, the P10s and the P90s, you can have the same for your net present value, and also you can have the same for your benefit cost ratio as well. So you probably see that they would be somewhat in sync here. So just looking at this graph, I don't have your P10s and P90s in this graph, but you have a good indication that your results somewhere between 0.4 and about a 0.6 or 0.7, and most around that central tendency of about a 0.7. So the distribution isn't particularly wide for this project. You can compare this with another project with a much, much wider distribution, and this is good additional information out of your sensitivity analysis to the extent of your risk. And ideally you want to see as narrow a distribution as you possibly can around your benefit cost ratio and your net present value. In a sense, that is, your investment is less risky. So potentially, we rank according to benefit cost ratio or net benefit investment ratio, but if by factoring in these distributions and you're factoring in sensitivity analysis, you may actually pick a project with a lower benefit cost ratio if you've got, let's say, 95% certainty that your benefit cost ratio is going to be greater than 1 or greater than whatever cutoff BCR you've got, compared to a project that's got a benefit cost ratio maybe 2 point something, let's say, quite a bit higher, but there's only about a 70% chance it will be greater than 1 because there's a number of factors that, if they don't go according to expectation, can pull that right down and is quite sensitive. So that's something worth bearing in mind. So what I'm going to do is I'm going to present in another video is what I've got this spreadsheet, and this calculates your distribution for your net present value and also for your benefit cost ratio, as well as looking at distribution for both costs and benefits. It's good sometimes to look at your benefits as well in terms of how their distribution, because your benefits are likely to actually have more of an impact in the sense that their sensitivity is going to be a lot greater than your costs. given you could be looking at, like I said, 20, 30 years out into the future, so you could have a very wide range of benefits, whereas your costs focus within those first few years, with your bulk cost being your capital costs. So this is for another presentation. This model is called POST, Project Outputs Sensitivity Tester, and in that presentation, in that video, I'll explain how you can use this model to actually calculate your distribution. Okay, well that takes me to the end of this video, this cost-benefit analysis, sensitivity analysis video. If you enjoyed this video, click the like button. If you want to know more about cost-benefit analysis or more about any other economics topics, whether it's demand and supply or game theory or even something I call now vegan economics, then you can hit the subscribe button. And I've got a number of videos that are already up there. And I've also got a number of other videos that I'm going to be publishing as well later on. And there's a lot of things in it if you're interested in economics and how economics can be applied in the real world and how it can actually be used. Also, my videos are normally published Australian time on Mondays and Fridays. Sometimes they can deviate maybe by a day or two depending on what's happening in the week, but the days to look out are generally Mondays and Fridays. Well, thank you for watching this presentation, and I hope I'll see you again soon.